Right, short video lesson on linear expressions, how they change in value and how they give us straight line graphs if you plot those changes. So it's about linear expressions, that changing in value and the graphs they give us when you plot those changes. So here's an expression of 5 plus 2x, 5 add 2x. What does it mean? It means two lots of x, so there's a multiplication sign in there that's not written, but we understand that it's there. So two lots of x, and it's 5 add the two lots of x. So you do two lots of x first, you do the most powerful operation first, and then you add 5. What is the value of this expression? As x changes, the value of the expression will change. So when x is worth nothing, we have 5, and we have do this first. Two lots of nothing is nothing. 5 add nothing is 5. That will be 5. When x is 1, two lots of 1 is 2. 5 plus 2 is 7. When x is 2, two lots of 2 is 4. 5 add 4 is 9. When x is 3, two lots of 3 is 6. 5 add 6 is 11, and so on. So what we're getting is that pattern of numbers there. Right. We'll now plot a graph to show the relationship between x, the value of x, and the value of this expression. So with the girl whose height was plotted, we looked at the relationship between her age and her height. Here we're looking at the relationship between x and 5 plus 2x. We're looking at a relationship now. So here's a graph of the relationship. X is plotted along here, and 5 plus 2x is plotted up here. So when x was 0, the expression was worth 5. So when x is 0, the expression is worth 5. When x is 1, the expression is worth 7. When x is 1, the expression is worth 7. So we're looking at the middle of the red square. When x is 1, the expression is worth 7. When x is 2, the expression is worth 9. When x is 2, the expression is worth 9, the middle of that red square. So that's the straight line we get. The graph starts at 5. It starts at 5, and it goes up in steps of 2. We go along 1, up 2, long 1, up 2, along 1, up 2. And you can see that in the numbers. It starts at 5, and it goes up in steps of 2, along 1, along 1, up 2, along 1, up 2, along 1, up 2. So you can see that pattern in the numbers. And there it's shown again there. So you go it goes through these points, 0, 5, 1, 7, 2, 9, along 1, up 2, along 1, up 2. So to describe the straight line graph, we must give two things. Where the graph starts from when x is 0, it starts from 5 on this axis. The value of the expression starts at 5. And we have to say its direction, the direction of the line. So this line goes along 1 up 2, long 1 up 2. Some people might say, well, it goes along 2 up 4. Well, it does. It also goes along 3 up 6. It goes along 4 up 8, along 5 up 10. You can choose any of those ways of describing its direction. So you've got those different ways of describing it. Now, those do all amount to the same thing. Going along 1 up 2 and going along 2 up 4 are the same direction. Okay, the lines, whether you use that pair of numbers, that pair of numbers, that pair of numbers, or that pair of numbers, they all have the same steepness, the same gradient. And it's a bit like, it's basically the ratio idea here. If we go, the gradient, as we define it in maths, the gradient is the up distance divided by the along distance. It's the ratio of the up distance to the along distance. So going along 1 up 2 is the same as going along 2 up 4, along 3 up 6, or along 4 up 8. So it doesn't matter which numbers you use, but you want to give the gradient as a single number. So we give it as, in this case, it is a gradient of 2. We do the up distance divided by the along distance. So 8 divided by 4 is 2, 6 divided by 3 is 2, 4 divided by 2 is 2, and 2 divided by 1 is 2. The gradient of that line is 2, and it doesn't matter which pair of numbers you use, because the ratio is the same for that, and that. What you do have to remember is the gradient is u divided by a, or the change in y divided by the change in x, if you wish to describe it that way. So the relationship between x and 5 plus 2x, we can call it, because this is the y scale on the graph, we can say that the relationship is y equals 5 plus 2x. That's the way people would normally describe it. The relationship is y equals 5 plus 2x. You can change the order. It doesn't have to be that way around. You can say it that way around. Y equals 2x plus 5. The important thing, however, that the 2 number, the 2 shows you the step ups each time. So it goes along 1 up 2, along 1 up 2. So the 2 tells you how steep the line is, its gradient, and the 5 tells you where the line starts from. We say 2 is the gradient, and 5, but we sometimes just describe it as the y-intercept, where the graph or the line intercepts the y-axis. And here we have a set of x and y values. This graph would start at 3 and it goes up in steps of 2. So the algebra rule for this relationship would be y is equal to 3 plus 2x. Y is equal to 3 plus 2x. This one, y starts at 7 and goes up in steps of 3. So y is equal to 7 plus 3x. Here the graph starts at 12 and goes up in steps of 4. So y is equal to 12 plus 4x. If you had to do a table of values for this rule, y would start at 6 and go up in steps of 4. So the y values would go 6, 10, 14, 18 and so on. Okay. With this one here, what's the y-intercept? Where does the graph start from? It starts from 6. This one would start from 12. This one would start from 10. This one would start from -4. What would the gradients be for these different algebra rules? The gradient of this line would be 4. That's quite steep. The gradient of this line is 2. The gradient of this line is a half. The gradient of this one is 2. The gradient of this one is 5, and so on. When the gradient is -2, that negative tells us that the line is sloping downhill, so to speak. The line will be sloping that way. So the gradient of this line is -2, the gradient of this line is -4. And just a little bit more about gradients. So here are some lines here. This line here goes along 1 up 3, along 1 up 3. So the gradient is the up distance divided by is UA. It's the up distance 3 divided by the long distance 1. So 3 over 1. 3 over 1 is 3. Here the gradient, the up distance is 2, the long distance is 1, so it would be 2 over 1, which is 2. Here you go like a long 1 up 1. The up distance is 1, the gradient is the up distance divided by the long distance, so 1 divided by 1. 1 divided by 1 is 1. This line here, the D line, you go up 1, but you're going along 2, so the gradient is U divided by A, so it's 1 divided by 2. 1 divided by 2 is a half. So the gradients for this line was 3, for this line is 2, for this line is 1, for this line is a half. And that will probably do for now. Thank you.